In this video, we'll look at the useReducer hook, which lets you manage complex state objects and logic. Let's begin. Earlier in this module, we saw how the useState hook can be used to incorporate stateful properties in a function component. useState introduces a very simple signature that includes a state property and a state updater function. Consequently, this works great with individual and isolated state properties that do not depend on each other. But the useState hook isn't a great choice when you're working with a complex state object such as the one you see here. This object here describes a training course with an ID, a title, a category, a count of the lessons, and an array of lessons in the course. You might want to put this in a single useState hook, but when updating a property within this object, you will have to manually merge the rest of the object in because the updater function just replaces the older value of the state variable. This isn't convenient and prone to errors, as you would need to do this in your event listeners and functions that have to update the state. Now, one might argue that breaking the object into multiple individual properties might work, but then you're intentionally restructuring the shape of your data to accommodate for potential incompetencies of the useState hook. And that is never a good practice. Additionally, in this contrived example of ours, let's say the lesson count value depends on updates to the lessons array. We want to update these two properties together because lesson count is dependent on the contents of the lessons array. With useState, multiple dependent state transitions are not possible. For all these situations, the useReducer hook offers a much better solution than the useState hook. A reducer is a pure function. In functional programming, a pure function returns the same result for a given set of arguments. This way, the results are predictable. In the case of React, a reducer offers predictable state transitions based on the existing state and an action. The job of the reducer in this case is simply to apply the said action to the provided state and return a new and updated version of the state. Here's what happens when we work with useReducer. The UI or the view in our equation dispatches an action. Think of an action as an instruction to do something, such as adding an item to an array. Along with the action, we can attach an optional payload containing the text and data to be added to the array. The reducer function then takes the current state object and the action and returns a new copy of the state with the action applied. Since our view subscribes to this state, this triggers an update and the UI renders to display the updated result. This produces predefined and predictable state transitions. It should also be noted that Redux, one of the most popular state management solutions for React, also uses the same working philosophy of reducers and actions. So let's look at an example to understand the useReducer hook. Start by downloading and setting up the project first and fire up the development server. Our example app here displays details of a course. You can see the title of the course, the lessons and their type, the category of the course, and we also have an Edit Course button. When the Edit Course button is clicked, we get the Course Builder interface, which can be used to set the title, category, and add or remove lessons. Of course, it doesn't work just yet, and that's what we'll work on in this project. In our app component here, you can see we are conditionally rendering either the Course Builder component or the Course Details component based on a state property that we've initialized using useState. Both these components have access to a state property called course, which holds this object which describes our course. As you can see, our course consists of a course ID, a title, category, a lesson count, which depends on the number of lessons we have in the lessons array. Within the lessons array, each lesson is described by an object with a lesson ID, title, and type. At the app component level, we are using useState just to hold this object so that we can feed it either to the course details component for viewing or the course builder component for editing. But it is the course builder component where we will need to build interactive features to allow users to create and edit this object, and that is where we'll work with the useReducer hook. So let's jump into the course builder component first. At this time, the course builder component is a simple function component that renders this UI for us. Here we are also bringing in the lesson builder component which uses controlled components to allow us to create a lesson and pass the lesson object up using inverse data flow using the onAdd prop when the add button is clicked. Likewise, when you try and delete a lesson, you'll get the lesson ID, which we can then use to remove the object from the lessons array in the object that describes the course. Finally, we have a done and cancel button. The done button will be wired up so that it sends the course object that we'll compose here back up to the app component so that we can store it in the course property there. So let's begin by creating a function called initState, which accepts a course object if we have one. If such an object doesn't exist, then our function returns a base object that we'll use to initialize our state. The purpose of this function is to provide a default shape to our state before we can use the reducer to modify its various properties. Now, if you are creating a brand new course, then you might want to set the course ID to a unique value. This project already brings in the UUID package when you run npm install to set it up. So we'll bring that in here. The UUID package is used to generate unique IDs and is a third-party package that I've already listed as a dependency in the package.json file. So if we don't get an existing course object to work with in this component, we want this function to create a new default course object with the course ID set to a unique value using the UUID package. Next, it's time to bring in the useReducer hook. But before we set up the useReducer hook, we need a reducer function which should accept the current state and an action and return a new and modified state object. So for now, I'll create a function that accepts state and action, and we'll build this in just a moment. Next, let's set up the useReducer hook. Just like the useState, we get access to a state object here instead of a single property, and we also get access to a dispatch function which we will use to invoke actions that will modify a state. The useReducer hook function here takes in the reducer function as its first argument, while the second argument allows us to accept a default shape and value to the state. We are using the course prop here because the course builder component will either let you create a new course outline or it will let you edit an existing one. So let's accept an existing course outline here as default. But what if there is nothing to begin with? In that case, we'll use the third argument, a reference to our initState function that we created earlier. What we are saying here is that the reducer should pass the initial value of the state as received from the course prop to the initState function and let it return the default shape of the state object. We have already built the initState function in such a way that it returns a default state object if the course prop doesn't provide us with an existing object. Now, the purpose of the reducer is to simply return the state and in doing so, perform updates and changes based on an action. We want to define clearly how we want to modify our state object using actions. So we'll use a switch statement on the action.type property. Our first action allows the user to set the title of the course. If this action type is received, we want to return an object which will now replace the previous version of the state. Here we want all our existing properties of the state, so we'll simply use the spread operator like so. But we also want to set the course title property because that's what this action is all about. So we'll set the course title to action.title. In simple words, the new state object should have everything from the existing state object except course title, which should be updated based on the title property being received in the action argument of this reducer function. We want to dispatch the set title action when the user is typing in the input field down here. So for its onChange event, we'll run dispatch and we'll dispatch an object where we'll set type to set title, and we'll also dispatch a payload named title which we'll set to e.target.value. As the user types, the input field dispatches the set title action to update the state object with the contents of the input field as the payload. This action is received by the reducer function which updates and returns a new copy of the state which the useReducer then merges over the previous version of the state. Now, to turn this input field to a controlled component, we'll set its value to state.courseTitle, which is how we access the value of the state. Let me just refresh this page because it stopped updating a while back. Let's also throw in a default case in our switch statement And this just throws an error because we don't know how to handle actions beyond the ones we are going to define here. Next, let's build an action named setCategory, and like setTitle, this one writes over the category property while preserving the rest of the state object as is. This action would be dispatched from the select category dropdown like so. Next up, we have our lesson builder. So first up, we'll set its lesson prop to state.lessons so that it has access to the state. Now, when a new lesson is added, we want to dispatch an action of type addLesson with the lesson object received from the lesson builder component. Likewise, when the user tries to delete a lesson, the lesson builder provides us with its unique lesson ID, which we'll use to dispatch an action of type deleteLesson, passing in the lesson ID. Let's now equip our reducer function to handle these two actions. First up, the addLesson action will return an object where we'll increment the lesson count by 1. Since the reducer function simply works on the current state, we can easily batch together multiple state transitions in one single action. So besides incrementing the lesson count, since we are adding a lesson, we'll modify the lessons array where we'll keep everything as is, and we'll add a new lessons object where we'll set the lesson ID, title, and type to values received from the lesson builder component. If we go into the lesson builder, you can see we are returning an object which includes a uniquely generated lesson ID and the lesson title and lesson type values, both of which come from controlled input components. Now, when we want to delete a lesson, we will decrement the value of lesson count by 1, and we'll use the filter method to return an updated array which excludes the entry for the lesson with the provided lesson ID. Simple. So our UI dispatches actions with payloads, and our reducer takes care of how they are to be handled. Finally, the done button here should check to see if we at least have the course title in place, and if so, it should send the state object back up to the app component using the course prop like so. We can now delete this demo course object in the app component, which brings up the create course button. I'll click this button now, and this brings up the course builder. Let's try to create a new course now, and I'll add some lessons, and you can see this works perfectly. Let's also try to delete a lesson. I'll hit done, and you can now see the course viewer interface with a newly created course. Let's click on edit, and I'll add a lesson. And it shows up the moment we hit done. The lesson count is updated too. If you peek inside React DevTools, you can see our composed state object at the app component level like so. As you saw in this example, the useReducer hook is perfect for managing complex state objects and transitions. You get a predictable state container with predefined actions that are the only way to update the state object. This also makes the reducer testable because you can produce predictable results every time. And because your application's entire state is encapsulated in a single object, you can easily persist this object to a store like local storage or a database whenever it updates using useEffect. So choose useReducer if you have complex state logic and transitions, and if you want state transitions to depend on existing values of the state in a predictable manner. Now, one of the great things about the Hooks API is that it lets you write your own hook, which you can then share with the world. Let's see how this can be done in the next and final video in this module.